Okay. Hello again.
Well, here, thank you, yes. Whoever's not here.
Okay, going to make a short announcement. Alessandro just told me that this is going to be sort of a nice kermesse, so he's going to do his talk, which is going to flow nicely into Rosa's talk without intermediate questions, and then only at the end we will stop and ask questions. So first of all, we have our friend Alessandro Ederoclite is going to tell us about the JPAS observing strategy.
I just checked that 6 years ago, I was speaking in a session with Alberto as chairperson and Mariano sitting in the first row about the strategy. It's like, you know, déjà vu.
So what's your talk next 6 years?
No way.
You already know, right?
I know the answers. Anyway, so I have a few people to acknowledge. So yeah, Alberto, Antonio, Carlinhos, Carlos, Hector, and Jesus, and a bunch of other people who contributed one way or another. So since it's football time, well, for some, less for others. So if you don't recognize some of those people at the end of the presentation, there's the solution. So if you don't recognize some of them, it's okay. Plus, my idea was to start from bottom up, hence I don't have a goalkeeper here. So anyway, so I'm going to guide you through this presentation through the main topics which are relevant for the strategy, going from the detector to the sky. And that, as you were, you cannot see Carletto Mazzone there in the famous run towards the Brescia supporters club. Anyway, those of you who don't know what Mortacci Nostra means will never be able to appreciate that beautiful moment. Anyway, so a couple of caveats. How does this work? This works like science working groups give requirements. And these requirements, as Silvia was saying before, they have been changing over the years. So at the beginning, it was one type of galaxies. That type of galaxies, we don't give them anymore. We wanted to observe supernova at the beginning. We don't observe supernova anymore. So things have been evolving. So all this information gets to the observing strategy group, basically me. I put everything together. I check if what is feasible, what is not. If there are two things which collide, one wants to observe Polaris and the other one the equator, goes like, there's a problem there. I can offer advice. I will not provide science priority. The science priority comes from the science, whatever it's called, the science, survey science committee agree and take a decision what is more relevant for the collaboration, what's not. It's not my job, it's your job. So in this case, I remove my hat as an astronomer. Once you guys have decided what is interesting and what's not, from my perspective, nothing is interesting for what most of the people here. Pardon?
Everything is interesting.
Everything is interesting, but with a very low rate. And I'll show you why in a moment. And so once we decided what we want to observe, how, when, why, I put everything in the JPAS tracking tool, kindly prepared by Tamara, and then PsyOps, Hector, does the observations, and we are all happy. So, sorry, didn't want to do this. So, the first thing, really inside the detector is the readout mode. The camera has 4 readout modes. I will not bore you with this. It's binning 1 by 1, binning 2 by 2. I'm going to get to binning in a moment. And then there's a fast and slow readout mode. So fast readout mode has higher readout noise. And the question was, this was an exercise that Tony commented last year, and I thought it was an interesting exercise. So is it worth it moving to slow readout mode so you have a less readout noise? So at the end, since mostly for the blue filters, you're always dominated by the sky. Sorry, for the red filters, you're always dominated by sky. It doesn't really matter. So fast readout mode it is. No questions asked. Off we go to the next. Binning is an interesting point. So you can forget about the readout noise, readout nodes. What you really care for is binning. And binning has been already a discussion for many, many years. Some of you, the ones who've been around for the longer, are probably already bored with this discussion. So the up until 6 months ago, the general consensus was broadband filters binning 1 by 1, it does no binning. Narrowband filters binning 2 by 2. We push depth. As Hector and Alberto commented, we are having issues with the reduction with binning. There's an issue with stars when they are saturated in binning 2 by 2. So in the short-term scenario, I don't think it's advisable or can even be considered to use binning 1 by 1. To use binning 2 by 2. So we begin binning 1 by 1 in broadbands and narrowbands. And then we see if we manage to fix this. If you want more discussions on the binning and saturated stars, Tony and Hector have more than the information that I'm able to handle. The interesting bit here is if you bin and if you don't bin, your depth changes. And this is what you care for. So, of course, we're going to make the slides available so that everybody during this week can look at these numbers in some detail or not. But basically what you have up here is binning 1 by 1 for bright, gray, and dark night. And the other 3 plots is to try to separate, right? So it's binning 2 by 2 as opposed to binning 1 by 1. Now, of course, binning 2 by 2, you go deeper with respect to binning 1 by 1. So, and of course, the main difference is in the blue bands, right? So it's very much is everything what you would expect. With binning 1 by 1, you may lose, depending on the brightness of the sky, you may lose an amount of magnitudes or another. So this goes for the science working groups and the survey science committee. So is this loss acceptable? With that loss, are you guys unable to do your science? Because if that is a problem, then 2 out of 1. Either we rebuild the camera, or we increase the exposure time, which means JPAS is going to take 20 years. So, you know. The distribution of the filters around the filter trace has been already discussed half a billion times. So again, some of you will remember. So there are technical reasons why the inner filters, they have to be the bluest, and the outer ring is supposed to be redder. So basically you go these ones, these ones, these ones, these ones, and then you go this circle around. You might have noticed that in fact, after these ones, you get these ones down here, not these ones, right? So this is because of Matt's suggestion, I think it was 3 years ago, and people were quite happy because this change was allowing a little bit more continuous coverage between the 4,000 to 6,000 Ångstrom, which in fact is the reason where most of the science group had their science interests. Most of, right? So the other thing is the selection of the broadband filters. So until 4 months ago, we had to perform this JEDI survey, and this was giving us a very strict constraint. We had to observe 5,000 square degrees down to 24.8 magnitude 10 sigma, and that was basically, apart from the fact that it was eating up significant amount of the data time, but that actually had a significant impact on all the any other broadband filter we wanted to use. This constraint doesn't exist anymore. Euclid managed to do their observations with another telescope, I think Subaru, if I'm not mistaken. So that's not a problem for us anymore. We're free. So we celebrate freedom, but the problem is once you have too much freedom, now you are able to choose. So how do you choose? So the important thing is do we actually need to use all the broadband filters? Do we want to go back to the original broadband filter tray? Again, for the oldest, we had a broadband filter tray which had U, G, and R. All in one tray was I may get it wrong. 4 U's, 6 R, 4 I's. Doesn't 4 G's and 4 I's. It doesn't really matter. They were all in the same thing. But OAHOTA has 3 complete trays, one full of G, one full of R, one full of I. So these are 3 options that we can explore. Antonio can expand on this, but basically, I think that the plot I like the most is the first one, which basically tells you, or my take on that is, between G, R, and I, R is the least informative. G and I are fighting with each other, but what Antonio keeps telling me every time I pass in front of his office and I hear Antonio yelling, I is, how do you say it? I is unnegotiable. So you take the fight with him, right? So I is unnegotiable. So is I enough? We want I, R, and G. We want I and something else. Again, it's up to you. The important thing here is what is the depth that we want to achieve? The thing is, we're not alone in the terms of software. So there are other projects out there. And so this is a plot that I did last year, I think. So if you can take, I think this is J+. Actually, I could leave it here. Check it out. This is J+. This is Panstar single. No, this is Sloan. Of course, we cannot possibly dream about comparing ourselves with LSST, not even the single epoch, but it's okay. The thing is, our strength is not the broadband. It's not the broadband. Our strength are the narrow bands. I will die on this hill. So, do we actually care about going to -26 in any band? what is even the point? So if the narrow bands can get down to magnitude 23, magnitude 24 is more than enough. Unless, probably I'm giving opinions and I shouldn't, but you know. So somehow related with this is we can, as I said, select up 3, 4, in principle, as many as we want, the broadband filters. But one of these broadband filters has to be our detection band. So we work, extractor, double mode, whatever. So one is supposed to be our detection band. So which detection band do we choose? If I is unnegotiable and I is the only broadband filter, hey, done. No sorry. If we decide to have, I don't know, I and G, really, then in that case, we may want to decide either I or G. Either. You want to do the 2 catalogs, one based on I, one based on G, you buy the infrastructure for UPAD to host it and you get a postdoc to do the job, right? End of the story. I don't want to hear silly things. Because I'm interim responsible of the UPAD and I'm doing it until the last day. And then there's the nightmare of the footprint. So, Alberto, how much time do I have?
20.
20. Oh, awesome. All right. The footprint, in principle, is trivial. It's the whole bloody sky, right? Now, there's an issue here. Our telescope is 40 degrees north, plus or minus 5 degrees. As astronomers, we're perfectly happy with this error. So, for the ones who haven't seen this plot, which is probably 2 people in this room, these 2 lines, which are supposed to be blue, and on here they are pink, purple, whatever. No, spoiler. So this is plus or minus 10 degrees from the plane of the galaxy. The funny points is galactic extinction higher than, I can't remember how much. This black line here is the ecliptic. Remember, this is going to be important. And this dashed blue line is the 0 meridian of galactic coordinates. It's going to be important later. And these 2 stars, which are marked as 8-point stars, because 8-point stars is the Mudéjar star. So one is, this is mini JPAS and this is JNEP, right? So what we want to have is to avoid the plane of the Milky Way for reasons that I personally disagree with, but because any normal person would start from the plane of the Milky Way. Maximize observability, because you don't want to spend your time there waiting for something to observe. Keep mini JPAS observable, and then we have with QSOs and Rosita Deutschland, and that's going to be commented in a moment. The original footprint, Alberto and Fernando Ballesteros a few years ago ended up with this footprint, which had a couple of issues, which were this dense. And I made the mistake of saying, well, Jesus and myself and other people agreed that this was a problem, because the moment you start having dents in a project with a camera like JPCam, you start throwing away data, and you don't want to throw away data. You only want to have the most efficient thing as possible. I wish I hadn't said this, because it opened the Pandora box, right? And the Pandora box was related with an original mistake, which was the selection of the original priority areas for J+. Some of the people involved in that decision are still in this room. One is talking to you. So, and just to make you enjoy how we understand that was a mistake, I have DR3, which is going to be made public tomorrow morning, here. So you can see this bloody thing, which is stripe 82, of course. Stripe 82 was an obvious thing that everybody wanted to observe, but we could never observe it. At some point, I was showing, this week we've been observing this. We had the regular work in progress meetings here at Safeca, and people were like, "You're stupid, why aren't you observing stripe 82? People were not saying you're stupid, but that was behind it, right? And I was like, there's the moon in the middle of it. So at some point you start to realize that there's always the moon, the moon is really, really, really affecting it. Hence, at some point, and this was 3 years ago, so I was not at Safeca anymore, there was this idea of, what if we change this with this? And in 2 years, we observed in that area much more sky than was observed on stripe 82. So, lessons learned, stripe 82, forget it. Stripe 82 cannot be priority. So, and here you go, list of things that have been sent over the last 2 years. So this was Carlos who sent me. The people from eBoss, they just published this. Rosa sent me a bunch of galaxies nearby, very nearby, Abel clusters. Note this area, which is one of my favorites. Gamma Codex, HSC, that was Alexis, Cipriano, and I can't remember who else. Renato. Then Stellar Group, sending stellar clusters, open and globular and dwarf galaxies. So that was Charles Bonato. Charles, if you're out there, one of the clusters you sent was actually out of the footprint of J+ tier 3. You see why I don't care, really? Wherever I point, there's going to be something interesting. So, this is why I can feel like I'm above all the decisions, because whatever you guys agree on is good for me. And then there's the issue of the memorandum of understandings. As I said, Euclid is dead, not completely, but basically the thing with Euclid is dead is perhaps we'll have to observe 1,000 square degrees eventually, whenever there's an agreement. I keep receiving this information, and we may or may not want to talk with JWST people. The Just Wait Space Telescope has been waiting for so long, we can wait another decade, who cares? Then Wave QSOs, who for whatever reason had this funny shape. This is unforgivable, really. This dent here is unforgivable. But this space here, and this is perfect. Yes, like 40 degrees on top of our heads. So this is what you want to observe. So if any of you wants to have a target to be observed, copy there. This is what you want. And then there's the Rosita Deutschland that you may or may not have heard about this Rosita mission, which is basically the daughter of Rosa, and it's a joint Russian, German, Max Planck mission, and they had a brilliant idea of splitting the sky. Half to the Germans, half to the Russians. And and of course, we have a telescope at 40 degrees north. So we cover beautifully this area. So of course, which is the area we get? This one. So if you want to do all the cataclysmic variables in the Magellanic Clouds with JPAS and Rosita, you're in a very good spot. Actually, we were speaking with Andres about the Magellanic Clouds. We're actually interested. So if you try to put everything together, you sort of get this. I removed the cataclysmic variables for obvious reasons, but basically this is what you get. So there's an obvious reason. There's an obvious region which is super appealing, right? Which is right in the middle, and then there's a funny regions sorry, from now on, I'm going to refer to this central one as the northern cap and to this split region as the southern cap. So in the northern cap, there's an obvious interesting region. In the southern cap, sort of also. So the logical, in my view, the logical thing to do was to have a 3 tiers system. So, which in other words means you have a first region which has to be small, contiguous, observable as much time as possible, and with the highest scientific interest as possible. And that is what is green there. Then the second tier, I screwed up the timing there. Then a second tire, which is the orange, and then there's a blue tire. The blue tire, the third tire is 12,000 square meters. So that is really something which is going to take something 15, 20 years. I'll be retired. So, you know, someone's children are going to take care of it. Tires can be modified. So, for example, there was this discussion, we may want to include the, what is it, JNAP in the tires. So of course, we can squish it and move it a bit up. No problem whatsoever. Have to check a bit the observabilities, but I don't see this as a showstopper. Now, the big thing is to tile all this. And originally, Alberto and Fernando came up with a very smart solution. And Hector has been reviewing it.
Smarter.
I'm not saying it's smart, I'm just saying it's another.
Okay, I'm going to intervene again, because I've been working with, of course, my interest is to where to point the telescope at the end of the day. So I was trying to figure out what is the actual pointings that we have to do. So we as Alessandro was mentioning, there was this idea from Fernando Ballesteros and Alberto, maybe you were also involved, I understand, of trying to minimize the overlapping of the pointings due to at the highest declinations. Okay, so the idea was to, like it is shown here, this is from Fernando, is to make a change of coordinates so that these overlaps is minimized, and that seems a very wise idea. And the idea was to use these coordinate systems to actually make here the tiling. You just put your tiles one next to the other in these coordinates. So we asked Fernando to send us the code to get the actual pointings. I must say that this implies that each pointing has to be rotated with respect to the north. Every pointing has to be different in that way, because we may infer that with that. And I don't want to make this story very long, but the question was that what I wanted to see is what is the gain of doing that And it was quite surprising that there is no that subject game. And that is something that we already discussed with them, because just in case we are missing something fundamental on that. But and mainly the reason is that you may be more efficient, but actually you are inefficient in the at the borders of the footprint, because you have to. I mean, the borders are defined in equatorial coordinates, but you are using another coordinates, so you need to do extra pointings in order to profile the whole edge of the perimeter of the footprint. And when making the numbers and executing the simulations, we see that the number of pointings is not that different. It's just a few percent. Okay, so and doing the other strategy that is the most standard to have the north up. Okay. Has other advantages. I mean, it's more standard. Maybe this is not a strong condition, but it could be something that makes the operation easier or more. It has some advantages in the operation side, and particularly at the beginning of the operation. So, long story short, we move to this strategy of north. Okay. And what else? Okay. Okay, now I'm going to show you very briefly a few realizations of this tiling. I am adopting the effective area that I've been mentioning a few hours ago, the one that is the result of buffering, the filters with this aggressive buffering. And what else? And adapting this north-up strategy, okay? You can see the sketch of PVT, JPCAM, there's 14 CCDs. And what we did is to optimize the step in right ascension as a function of the declination, but one has to take into account that you don't have to take the coordinates of the center of the detector, because this is the problem that you have is that you have 14 CCTs that are monolithic. I mean, you move up and down, you will have a difference in declination between these CCTs and those. So in order to define the step and avoid gaps, you need to rely on the pixel with lowest absolute declination in order to do the steps, because otherwise you will get gaps. And this is I'm going to show now that this is going to produce different overlappings depending on the CCT, the projection of the CCTs. Okay, let's move on. So, for instance, you are seeing here, I'm showing here one of the versions of the final footprints. This can be changed. There is no problem. We can inject whatever areas that we decided. But just for one of the possibilities that Alessandro provides me, you can see one of the regions that had high declination. You can see the blue contour, which is the limits of the tire free, in this case, region. And the crosses, the red crosses, are the coordinates of the center of the camera. And now here we are only seeing CCD number 1. Okay, and you are seeing the pointings that actually are needed in order to cover that area. You may say, okay, why are you observing here? Well, we need to do that because otherwise we could have problems. Sorry, here. Okay, so this makes things funny. Okay, so you need extra pointings outside the footprint in order to cover everything. This is just I just wanted to show you this, and I want you also to pay attention to, for instance, here with CCD number 11, which is down in this particular pointing that is north, you have the smallest overlapping between pointings. But this makes that other pointings has larger, has the largest overlapping, okay? You can see here the overlapping. So the overlapping is going to be a mess, I have to say. And on top of that, you will have 3 more exposures that are the different ones. Okay, so everything is going to be a mixture.
What's the smallest overlapping you're requiring?
I'm taking the effective area, the sizes of the effective area, and I'm adding an extra because of the stability of the vignetting pattern that we can achieve right now. We are getting an stability that has a sigma of 15 pixels. So I am assuming 2 sigma. So in order to be sure that there is no gap between these central exposures, then on top of that, as I said, this length of half a CCD. Okay. And okay, that is I'm finishing this. This is just how it looks like in 4 different positions in the sky of the different tires. In green, for visualization, in green you have the tire 1, in orange you have tire 2, and in blue you have tire 3. 3 regions to check things are working. And in this case, you are seeing the whole 14 CCDs one on top of each other, and how and the pointings that are needed that are the right process to do that.
So the minimum overlap is happening near the condition 0, right? That
Yeah, sure. Of course, things are tricky here because
In the application 0, you are working with Fernando's coordinates.
yeah, sure. Yeah, the point is that yes, that we've made some tests, fair comparisons, and it seems that there is no. It could be a few percent or even less difference in number of pointings, but actually, this is why we are moving to this. But it's something that we can discuss.
I have sorry, can I ask questions now, or should I wait until later?
Let's just finish.
Okay.
I have 3 more slides, and then there's Rosa. Let's just finish the 3 of us. That was your mind. I think I still have just 3 more. The cadence died in Madrid 2019. We used to have beautiful 2 + 1 + 1. There was this consensus among the collaboration that we wanted to finish fields soon, quick and dirty, and that basically means no supernova. And then there's the topic of the seeds, which Rosa is going to address again. So the seeds are very easy. Those are the pointings around which the survey is going to grow. And the idea is they have to be in J+DR3, because like this is an area that we already know, that has already been calibrated. They have to be observable across all the year. They have to cross at about 50 degrees. There can be an exception, which has to be well justified. Scientific interest, and mini JPAS is seed number 1. Everything else develops from JPAS, mini JPAS being seed number 1. I don't see any option around this approach. These are the observabilities, and these are the 4 seeds, which of course, since mini JPAS is here, this means that I have to move tire 1 a little bit north. As I said, no big deal. Open questions. This is for the SSC, of course. The heads of the science working groups will permeate these questions to the rest of the collaboration. So what happens if we cannot use Bini 2x2? How much are you going to cry? You're not, let me tell you, you're not. Because if you are, you're not using JPAS at all. Are you still interested in doubling the exposure time in tray 4? Be my guests. Which broadband filters do we want to use and to which depth? And which one is the detection band? Any comments on footprint and seeds? Footprint can be changed. I mean, 10 degrees more or less is really not an issue. 60 degrees or 20 degrees, 30 degrees, that starts to be an issue. Moving the whole footprint, that is a problem, but expanding it like 5 degrees more because there's one field, that's really not a problem.
But it can be a problem. Moving 10 degrees can be a problem.
If it's south.
If it's south, it can be a problem.
Yeah, I just to be clear, it can be.
It can be a problem.
Yeah.
Well, if it's a problem, it means it's not going to happen. And it's easy as this.
Why problem? I mean, it's a subject that has to be discussed.
Right. 10 degrees in the wrong direction is not a problem. It's not going to happen. Done. Seeds, they can be moved here and there. Again, 10 degrees is not a big deal. You ask me, M31 is obvious. I mean, if anyone with some self-respect will have M31 and M32 as their seeds in the southern part of the survey. No questions asked. And that should be self-explanatory. If it isn't, that's your problem, not mine. I have a series of suggestions. I will share these with you, but my view is first year is science verification, mostly the first 6 months. The first 6 months we start with binning one by one, remember. So that's non-negotiable, right? And then within that, can do whatever you want. You want to try to ask to do all the filters like the blue filters with more priority than the red filters since the beginning, fine. But in the first year, that's going to be with binning one by one. End of the story. You want binning 2 by 2, you reduce them yourself, and then you tell me. So yeah, that's the thing. And Rosa has more.
As I said before, we just keep questions for the end and then we bombard them with all the questions.
Okay. Okay, sorry. I was expecting only a few minutes to support most of the work and the preparation of the document.
Perfecto.
Of the footprint.
Porque él es un pesado.
So, but then I was preparing a lot of figures, nothing really important, but the main idea is to reinforce some of the point that we make in the document that we prepared 2 years ago, relating with the survey strategy requirements from the Galaxy Evolution Working Group. The main conclusion is that, in fact, 90% of the project for Galaxy Evolution required all the filter set. And this is not negotiable. So that means that, and the main reason is that obviously in other case, we don't get any homogeneous sample in terms of emission line object, for example, which is very, very, very important for all the Galaxy Evolution project. Also, there is a very important point that we made in the document related with the needed of, in addition to, let's say, cosmological field, like, for example, the mini JPAS, we required also a field where we can see nearby galaxy. Also a field where there is nearby galaxy cluster. The main reason is that the one important aspect of the JPAS is the possibility to do IFU-like study. And for that, we need to have a spatial resolution and we need to observe the closer object. Obviously, there is a lot of projects that can be done only with integrated property, but that's something complementary, let's say. Okay, so, well, this is one of the field where one example where you can see a really big nearby galaxy that has more than almost 10 minute diameter, but close to them there is a band of galaxy that has size which is similar to the galaxy that we were observing in the Khalifa survey. That means that it has size around 1 minute. Also, there is another galaxy which is something larger that will be observed by the IFU mode, in the WiFu mode. And also a smaller galaxy, but can be also result typical of the galaxy that has been observed already by MANGA. So that means that we need all these kind of galaxy and size and distance of the object. Let's see, this is the same field, and here it is the Stefan quintet. So that means if we do a continuum, no, we don't want to prioritize a field or Ponti, but if we do in some continuum way, we just find in the same field big galaxy, intermediate galaxy, but also very, very interesting group of galaxy to understand the environment and the effect of the environment in galaxy evolution. So, well, this is another example of the nearby cluster that we need to observe. And the importance of this is that with JPAS, we can do also, in addition to the IFU study, also we can mapping the property of the galaxy to more than the virial radio. So, and this is quite neat, because nobody has already been done for a lot of objects. Here, this is the only example that we have already done with mini JPAS. This is a galaxy in mini JPAS, the bigger one and the closer one. This area is the area that has been covered by MANGA, but the galaxy, as you see, it is significantly larger. And here we just estimated, which is the radial distribution of the ages of the standard population as a function of the effective radio. You see that the MANGA can cover only the inner 1/2 la radio. However, with JPAS, we can go further. So that means that even for a smaller galaxy, we can make a IFU-like study to the outer skirt of the galaxy. Well, this is another sample by Julio in mini JPAS, where we see that that because we have most of the cluster, the big cluster that has been detected in JPAS, we can make a study of for example, of the specific transformation rate as a function of the virial radio. So this is neat for all the galaxy evolution study. Taking into account all these ideas, this is why we sent it to Alessandro, many of these pointing where we just selected the Abel cluster and also nearby galaxy. However, at this moment, I was sending only because at this moment, 2 years ago, we thought that we are observing over 20 degrees in declination. So that's why there is no any other point behind this declination. So based on this, they selected right now for SIT. which is the one nearby galaxy, Abel cluster, mini JPAS, and the other cluster. That's one example. This is the first seed. This is a big galaxy, interesting. But I mean, it doesn't matter that the seed could be this or another one. The only important is that when we go to the field, we try to observe the whole footprint. But this is the position of this first galaxy, and well, unfortunately we cannot see, but this is N33, which is very close. So that means if we go to continuously in the field, sooner or later we are going to find a big galaxy or a very interesting object. That's the other of the seed, which is this Abel cluster. This is another one. This is the two clusters. Well, that has been already selected as a seed, but it doesn't matter whatever we select, because this is the complete catalog, where you see this is the mini JPAS, this is the net. So that means that around also these 2 points, there is a lot of nearby objects that could be very good for galaxy evolution. Okay, I don't know why I have this one. Well, this is also the footprint already proposed by Alessandro, and also in relation with this, there is a lot of discussion if we go to the quadrilateral plane or not. For us, in the case that we decided to go, it will also be very good, because what's that? Oh, I don't remember. Okay, well, this is the cluster. Sorry. This is a cluster that has very close to mini JPAS. So that means that in the case that we decided to start before mini JPAS, also very close to mini JPAS, we are going to find also very nearby object. And with respect to the footprint, the discussion was to go to the quadrilateral plane. That's quite good, because in that case we will go with Virgo, which is really quite neat to be done. Also, I think that JPAS cannot finish the survey without observing this one. In some way we had to do it. That's it. So that means that in principle, the only important requirement for the galaxy evolution working group is to observe with the whole set of filters, and also not picking one pointing on another. It is important to do continuously, because soon after we are going to find a very nearby galaxy, and also nearby cluster where we can do the IFU study, which is quite neat for galaxy evolution and also for the project. Because so far, I didn't say at the beginning, there is no IFU that can do any observation of big galaxy. And also, as I mentioned, for example, MANGA, which is the more extensive IFU light survey, they has also observed only the inner part of the galaxy for most of them. And that's it. So it's
We're going to ask Alessandro to come here, but he's here. Rosa, don't go away.
okay.
In case you also have questions, and Hector, wherever you are, can also come here.
And 3156 filters.
Okay, we'll get you that. Alexis.
So if we go with 1 by 1 beam, it means that our simulations are outdated for the strategy, and we have to do the simulations. It also means our trays 3 and 4 are most efficient trays because they're not loading anything. So it makes sense to observe them because they are performing better. So it will help us to keep us on track, even if we don't increase exposure in the blue trays. And I have one comment to Rosa. I mean, there are much better catalogs than Abel. We have to retire Sir Abel. Like, Since a while, I'm sorry. You know, please talk to me about this. We have catalogs where we understand those classes. So.
We're waiting.
So, so just before about binning, just one curiosity. Suppose that after ETV comes here or somebody finds what's possibly the solution that maybe in January, that turns out that 2x2 binning is possible, right? Then it's in principle possible to do it. Is there still a case to do 1x1 binning anyway because of better control of the data or something like this, or once it's solved, then we go back to something, no, we can be done and it should be done. It's just a hypothetical, but.
I hope that scenario happens. If it happens, then we may want to reconsider. That would be awesome to have a reconsider.
All right, so thanks. Now my question is the following. When you have the, what do you call that, rot and new solutions, right? It's my impression that what you have is something that at zero declination has basically zero overlap between the tiles, something like this, right? But at zero declination is exactly, it's very rare that we will observe there. The question is whether we shouldn't make, so what we're trying to do is that we're putting a flat sheet of paper on top of a sphere and we're making it fit. Of course it doesn't, so that's why we have these little overlaps. Shouldn't we try to actually make the minimum overlap right at the center of the north piece?
Welcome to Fernando's coordinates.
Yes.
That was actually the whole.
That would make things more efficient, right? Because in the figures that actor showed, it was in the zero declination. So there's a way to do something very similar, except that we change to different coordinate. Let's say we put the, anyway, to Fernando's coordinates, as you said. Yes. Okay. Right.
Let me be honest. I've been working for the last weeks on that and doing fair comparisons with both strategies. I found that there is no that strong difference. The reason is because of you need to profile the footprint perimeter with the coordinates that are not the ones that you are adopting. The definition is made in another coordinate, so you are inefficient because you have to do like this in order to, like a so.
So is that important to have? Why don't we leave it like this?
Yeah.
Why don't we need to have like a smooth? We can have in the borders, we can have the borders.
It's another possibility. Another possibility. We could define the footprint in the other coordinates.
I think we lose more by more efficiency by having too much overlap than by having borders being like a bit messy. I mean, it's just an impression, but you know.
The other thing that I shared with them was what is the maximum overlap that we have, and actually this happens in the northern pointings, and actually those northern pointings belong to tier 3 that you see you was going to see them. But the worst case was not that bad. I mean, was not that catastrophic to think about. Oh, thank you. What I mean is that should be the worst overlap that we are facing with north strategy.
Oh, that's 80. Okay.
That is a problem. I have to say that I realized different details that I didn't take into account, like moving away from the footprint in order to complete everything. And I mean, I can do again the fair comparison with the Fernando strategy now that I have all the details in place and do it again.
So just a single number. What is the total amount of overlap that you get in that case? Do you have an idea, just roughly? A few percent?
This is a visual inspection of the overlap. It's not a. In order to have a number, another possibility is to throw points randomly and count them. This could be something that I thought about.
Multiply the area you're covering and with your number of points.
Yeah, maybe using hill peaks or something like that. You are sure that you are being fine with the area. No?
Yeah, but
Exactly.
just think that, I mean, we had this discussion like 3 weeks ago.
Yeah.
The number is not large because actually the effect that is not too large either, that you lose on the sides by having this seesaw shape in the other coordinates, is basically compensated by this. So you get the same number of pointings, basically. So maybe one's like 3 or 4% more, the others were like 3 or 4% less. It's the same order.
All right. Okay. Then in that case, it's what's most convenient for the observers.
That they convinced Fernando, who was the father of the thing, and me, who was, I'm the uncle. The risk of having an extra free parameter, which is how you rotate the camera in every point, actually, I mean, I have to say, it looks, if you want to say it and they don't listen to me, silly. Oh, come on, who's going to do? No, but things can go very wrong. Okay.
So I have 2 questions, one on binning and one on the footprint. I'll try the binning one since we're close to that topic. So as I understand it, the problem relates to overexposures, and the overexposures have been detected in the broadband, right? My understanding is correctly. So the concern is that if you bin 2 times, you get an overexposure, but that exposure is only something that's been checked in the broadband observations, right?
There are 2 issues with the binning.
Yeah.
2 by 2. One is what Alberto showed us, and it's related to the correction of the bin, the subtraction of the bin.
Yeah.
And the problem is that you have very few pixels in the poster scan, over the scan, whatever, to actually characterize the behavior of the bin. And this makes difficult because you don't have data to do it properly. This is one problem that I don't know. I understand that this is something that we can discuss with Caroline B2B whenever other more important problems are being fixed, and whether this is something that we can change. The other one is that when we have saturation with binning, we actually some regions are affected around in the nearby of that saturation, and that is more. I would say that this is it's also something to consider.
Yeah.
We have seen this in broadband filters, so we expect much less flux.
Well, that's what I was getting at. So if it's something that's been tested in broadbands and saturation, maybe saturation isn't the main concern there. But that particular problem would most likely go away in narrowbands, right?
It's going to be less for sure.
Yeah.
We have no data yet to see
right.
To assess what is the impact.
I mean, it seems to me that to understand the problem and make any decisions about it, some narrowband commissioning data is needed to actually figure this out, right? It just seems like the information just isn't there to make a decision. My follow-up question, but can I ask the second one?
Please.
So the second one was about the 2 tiers of the footprint. So so this adds up to about 8,500 square degrees, which is broadly speaking what's expected to be observed anyway. I guess my question is, why do we need to have a strategy that says tier 1, tier 2, when we know that we need both? So isn't the real question, and we think we can achieve both, this 8,500 square degrees, isn't it just a question of what order we do things in to maximize the speed with all the stakeholders in the discussion?
I think this goes back into the JPaS experience. JPaS is taking significantly longer than we expected. And at some point we had to start making changes in the footprint and the priority areas. And it would be a pity to repeat those mistakes.
But on the other hand, the South Galactic Cap is a small area. And there's a large chunk of the year where we're going to be sitting over the South Galactic Cap. And it may be inefficient, but on the other hand, it doesn't need to be as efficient as it does in the north. So, I mean, I'm not sort of arguing. I mean, I think there's a lot to be discussed about what you're putting forward for the South Galactic Cap. Maybe the Shrub 82 is out of the question, or you know, I understand the constraints. And just for the record, the weird choice that we've made was entirely designed around the requirements of JPAS. So, well, actually not entirely. We've had some, our colleagues also have some drivers that pushed us in this direction as well. But partly we sort of said, well, you guys want Stroke 82 first, so we'll go along with you. So this is, so I mean, you know, we're sort of trying to come up with a plan here that works, and it's quite difficult. Weed is a difficult truck to steer, right? For us to turn at this point is quite hard for us. But anyway, I'll say more about this tomorrow.
That's north of the southern cap is unavoidable.
Well, exactly. It's just a question of what order you do things in. I think it's going to happen.
Yeah. You and then Renato?
Yeah, I mean, I actually wanted to comment on similar things. So same on the footprint. Also, I think, so the footprint is certainly one of the things that had more discussion already, and where probably actually most of the groups can comment and discuss most. I think it would be good to really be clear on what it means 10 degrees difference, it's acceptable, right? Because 10 degrees in right ascension, indeed. In declination, it's not so trivial, right? So maybe if we go northern from 40 to 50, that's fine, but going from 20 to 10, that's already a big difference.
10 degrees north, easy. 10 degrees south.
Right. So I guess approximately you would put, based on your experience, the lower limit you would really put, what is it?
Which we, yeah, let's see the clock.
I have to go to the other.
This.
Well, tier 2 would get to 0, right? Still.
No, tier 2 gets to
20, basically.
20.
Like 19.
Well, in the south.
in the south.
Ah, okay.
Ah, yes.
But okay, sorry.
Zero.
Yeah. I mean, on the north, it really doesn't make sense. I think it's the south is where.
The south, I'm trying to push it as much as I can.
All right.
There was another slide with the seeds in it.
The one with the seeds on it.
Seed in the south, we're not seeing in this block.
So the one with the seeds on it has. So this one has a different footprint.
Oh yeah.
Because is the footprint that doesn't include mini JNAP,
Yeah,
right?
but it doesn't need to include JNAP. It needs to, JNAP needs to be covered, but you don't need to do from 100, RA of 100 to RA of 280 just to cover JNAP. I just don't.
Well, this is something to discuss.
So that's the thing, right?
Alessandro's proposal is just to squeeze it in array and go a bit higher, right? Which is possibly for some things.
So if it was me, the reason why my original proposal was this is because, in my opinion, I could happily skip JNAP as a seed and having it in the first tile. But then in the conversation with the SSC, the idea of having JNAP as a seed, hence in tile 1, was suggested. If that is the case, that this tile has to extend north one way or another. If I want to extend this north, which is again the 10 degrees as I'm saying, these 10 degrees I have to get them somewhere, and that somewhere is by squeezing on the sides, or by moving these up.
That's all lost. That's 100% lost with regards to QSO.
Right, it's a
big deal. I mean, it's not a large area, but it's one of the few things that we've agreed. And
from my perspective, is you talking to Silvia, talking to Renato, and then you guys come to me and say, I want this, I don't.
Can I ask something? Since you mentioned my name and I've been abandoned here.
You still live.
I was about to tell you to say something.
Still fat and alive. So I have a question. I have actually two questions, but for Alice, since this was mentioned just now. But sorry. About the question of tiers. This is an interesting point because I'm assuming that a lot of you're using priority as observability based on JPass. So if you're using that, it would be nice to know exactly what was like the annual variation of area that the weather allowed JPass to do. How much is like the fluctuation? Because it's going to be kind of random, right? At that particular 1 and 2 tiers, they are there. And if there's any trend of getting better or getting worse. So I'm just saying that part of this is just based on fluctuations. So if you get one tier or no tier, just the main area of JPass, plus minus some fluctuation due to weather, for example, that will be pretty much the footprint. So I would probably use a separation in tiers for scientific return. So this is tier 1 because we can, we can do a joint work with, let's say, the NAP, not the JNAP. JNAP is one single thing, but NAP folks. Or it's because we can help, we even get some science back relatively fast. So I would do tiers in that sense, mostly based on the scientific return that you get. Without, of course, there are, of course, things that are very badly to observe. No doubt about this. But in this main region, it looks like that it'll be interesting to see what's the variation weather-wise.
Renato, can you see me blinking between these two slides?
I can't even, wait a second.
Look at the center.
Yeah.
Right? So that's how the first tire was born. For the Southern Cap, the story is different because the Southern Cap is, the Southern Cap was basically guided by Moon plus EBOS. But because basically EBOS was I'm sorry, it's not my fault. But EBOS had two things. One was Stripe 82, which is impossible, and the other one was away from the moon. And that was like, I'm me, happy, Carlos happy, everybody happy. So yes, I mean, Renato, it may sound like I'm crazy, but I'm not. So this is trying to maximize science return. Here I have all the things that have been proposed, and wherever there's a higher concentration, that's where the tier 1 is. It's not like I'm drunk.
But it's more complicated than looking at a plot of all the surveys on top of each other. Right? We know that we're doing we know we're doing tier 1 and 2 anyway, right? And that, I think that probably includes Stripe 82 eventually. I have no particular vested interest in Stripe 82. I know some people in the room do, but it isn't impossible. It is doable. It's just inefficient. Those are two different things. And the idea that you can just put a plot like this up and say, these are all our drivers, and we can just digest the priorities this way. It's not a fair representation of the situation. The situation is that there is some science that's lost, other science that's delayed, and those two things are not the same. If you ignore the requirements of Weave QSO, that's area lost, and you're not going to get it back.
I'm not.
No, I know you're not. You're not totally ignoring it, but I'm just saying I'm not accusing you of ignoring it in this plot. But if we don't look at the strategy from the perspective of loss and gain, not just coverage like this.
The thing is, I cannot steer a whole survey for one science case. I can give something to one science case, and I can give some other to other science cases. And anyway, this conversation, this discussion about prioritization is not my job. So actually, I can do whatever you care. I honestly don't give a damn because it's not my science, it's not my job.
I'm just
so yeah, you can put it up, but you have to talk to Silvia, not to
Actually,
me.
Silvia has been trying to speak for a while, so please.
No, I mean, I think. this discussion is not what, I mean, I think the point here is to show what is the current scenario, the current picture, based on what have been the different requirements. And the point here is now, in principle, we should be already into different parallel discussion to really understand in part what is, following a bit what Matt was saying, what are really the requirements also in terms of timing and in terms of priority, because if something is not done now, I mean, it's not really about giving a bit to everyone, because a bit might not be enough for a specific science case, but you can give everything to anyone, and to the others, it would just arrive maybe a few months later and with not a significant loss in terms of science impact. So I think the whole point is to set up priorities also based on really urgent timing matters, which is what actually we need to report.
That means that.
Right. So one thing, Ali, don't take me wrong about this. This is a fantastic job. Tier 1, tier 2, they are there, and they're going to be observed. So the question that I was asking, and it would be nice to know at some point, how is the weather affecting this over time with J+? That's one question. The second one is that JPAS will have to get a relatively large area that we don't know yet now how much it is, with all filters. There has to be a large area for JPAS, what's JPAS, right? But we're gonna get, I don't know what, 400, 500. And so I'm sure that this region would be within tier 1, whatever is there. And it would be interesting to know also how much this area now is, seeing using, for example, the success of J+ in terms of weather.
I think that was the main. I think this is actually what will follow up on what the groups should report about. I think Rosa already mentioned the requirement for galaxy evolution, which is probably the group that has the strongest requirement of having full filter coverage. And I think we already discussed this many years ago, that we should guarantee a couple of hundreds at minimum square degree per year with all the filter coverage, because that's the JPAS representative survey.
Right.
And I think it's absolutely out of discussion that that's a priority.
Right. So after that, then you can answer your question, is the second exposure on the red filter are going to impact science? Because you're going to be able to test this there or not, after you have this area. I had one final question for Hector, I think, about the binning. So I guess it's Hector, maybe it's Ali and Hector. So from what I've seen there, this issue with the features that appear to look like blooming, and in the binning, 2x2 for the broadband, it's not. Are you sure it's blooming? Because as I understand, there seems to be something that's not clearly understood what it is. From what I discussed with Tony, that actually it may be something that is solvable by, and people that, you folks, can maybe not. I don't see why maybe in 2 months you find out, oh, okay, we can correct this. I understand why JPAS would start with 1 by 1, because you at least guarantee that data is going to keep flowing. You're not going to wait until you fix that problem to start. But it doesn't, you're sounding very fatalistic about the binning. And I was wondering, what are the hypotheses right now? Because the blooming, I think Pepe had some questions about the blooming looked weird. I don't remember exactly what was the reason for that. It's very technical. So I was just wondering how confident you folks are that this is just blooming and that you can fix it or not.
My questions are for the engineers.
Yeah, actually, I think Tony has. I think
these are not
has a very
for
good
the
idea.
scientists.
So I think he understands well what's the origin of that regarding the saturation, and regarding the bias, the removing of the bias or characterization of the bias. Yes, it could happen that we find a solution eventually. Now,
I want to interrupt myself first here, because I want to apologize to the large scale structure group whose time we're actually invading for the last 20 minutes. I hope you're interested in the discussion, because this is supposed to be your.
I mean, in principle, all groups who could go now split and have discussion.
So you don't have the room, you can have any room.
I also want to make a point about bidding. I also have the feeling that it's still too early to take a decision. It's also because it's something we really did not have any time to digest. So we should start taking data. However, we can take data. We'll see how really the result is. In the meantime, we keep in the back of our mind that we should check how much this 0.3 magnitude difference affects tests and mocks and results to see for the next couple of months how this affects science. But I don't think we're ready to answer that in any way this week.
On that point, is the commissioning planned? Further commissioning tests planned for this? For binning, is there more commissioning tests planned for this or science verification tests planned for this?
Sure, actually, we have to intensively test it in the narrow band. We don't have the opportunity to do so. We'll test it.
It is not clear yet.
Pablo was also waiting there.
Yeah, sorry, a bit going back to the old discussion, but just to know whether that's an option. If you go back to looking at the footprints where you were discussing your proposal and then, yeah, those two ones, which I understand here that the point was that if you want to include net, then you need to go up in declination because otherwise you have a bend there and you'll be very efficient. But going back, I'm sorry to go back to Fernando's coordinates. Could you, if you were defining your limits in a different set of coordinates, could you include net, but then having say more, keep the overlap with or is this something that you could?
Es un recubrimiento de una esfera por plano tangente. Eso te va moviendo
Sí, but
no, Mariano.
it may end up in a nightmare. It may end up in the problem we're trying to solve. It may end up coming back multiplied by 2. Because at the end of the day, you end up having rotated field, if I understand what you're trying to suggest. And that rotated field is exactly what we're trying to avoid because at the beginning, we're going to do the observations by hand. And when I say by hand, it means the operator has to put the coordinates and the rotation of every observation by hand. So you're increasing the chances of a mistake by a factor of 100. So no, unless it's really, but it doesn't look like it.
I have a line that you are in the line. Alexis, you were the one to say something.
Well, I mean, currently it looks like we will, this proposed footprint will overlap with Euclid quite well, which means that we could kind of modify our priorities on eventually using Euclid data for the lensing calibration. Euclid will release the data, first in the north and then closer to the plane. So it might make sense to to do the timing of observing this green area from north down south.
The timing actually is you basically grow in stripes around the seeds.
Right.
So basically,
I calculated once that you can do continuous stripe of what 5 degrees.
Right. Yeah.
Right.
Stripes like this or like this?
Like this.
Right?
Yeah. For example.
Stripes. Oh, did I say?
But how about the is that a problem for you or?
Well, I mean, we have a detailed plan that's already being ripped up in these discussions, but we'll see if we can rebuild it. But so surely the idea of a seed, the array increase. So as time passes, you get increasing array, moving right to left. So surely the logical thing to do would be to have seeds at the lowest array in the north, and then so it's clear. Mini JPAS is an obvious choice. There's no question, of course. You're going to have a seed there. It makes sense. But then surely there needs to be seeds to the right of the north and to the right of the south, so you can chug across from right to left.
Well.
But usually there are more time available at the edges because you avoid the certain array because of galactic plane. That's a typical server strategy. I've been through that many times.
Sorry, say that again?
Because you avoid the galactic plane,
Yeah.
you have lots of hours that cover edges.
If you remember many years ago when Fernando made those beautiful movies,
Yeah.
they always covered like
It's because you're stuck,
flashes from the.
you're stuck with nothing else to observe into the galaxy.
So at some point you start piling up observations around the edges.
But then the JNEP is not a great choice because it's right at the end.
Yeah.
Don't ask me, I was asked, right?
Yeah, sure. But it's, you know, it's a.
So again, see this region here, and this region here, this is J plus, right? And this region here, so basically the corners, they start being populating quite fast. Because, as Alexis was saying, at some point you are here and you'll go like, what do I do?
Sure, but that argument sort of goes when you get to already 130, 150 hours.
That's correct, yeah.
So you need to be starting somewhere like this because your solution doesn't apply there. Right, like that.
Because at this point, for example, why is that? I'm not a fan of my own seeds, but all of them I make in the infamous document that has been circulating. I explain why these seeds are this and not others. So this one is obvious, right? So no discussion. I need one seed here. I put a seed there because it is far away from mini JPAS and it's in the Rosita Germany footprint. Otherwise, if I had been a normal person, I would have put it up there, which is the normal place to be. This one is here because it is it fulfills the.
That's flexible. That's what,
me too, I'm
very much
flexible.
stress on this.
It fulfills the EBOS is one. I think it was one of the galaxies or one of the clusters, whatever that Rosa passed, and same goes for this one. Again, nobody asked, but I would have put M31 here.
I was going to suggest.
Well, I argued for 20 instead, because this breaks with our agreement with the Weave colleagues, which is, yeah. I mean, I think that the tension regarding these other Gaia and Lofar in Weave and how much we're going to annoy them with this is somewhat alleviated by the fact that the surveys are delayed, so we're not starting here. So we have time to sort of breathe and figure this out. But you know, I was asking them try to go as high in deck as they can, and I was asking you to go as low in deck as you can. And so, you know, 20 degrees, but still within the green is enough to sort of kick the can down the road. But I understand there are other priorities.
Here, sure. This would be doable, right? And actually, this would be almost ideal for a reason that you're not going to like, because basically from here, because of air mass, you naturally go up. So basically, this means that this region gets filled going from bottom up.
So not from right to left.
Yeah, from right to left, and that right.
Diagonally.
That is basically.
It's going to go like this.
Yeah.
Yeah.
It's hardly going to go south, and it's going to move.
Well, I mean, then you just told me I need to go even further south. But no, I take your point.
Because
Short ignorant question about this. I arrived like probably missed the point. You're saying 1 times 1 binning instead of 2 times 2. I remember all discussions many years ago with kids. It was said that he was advocating for 1 times 1, but the UBA said no way, it's impossible, right? For some reason now it's possible. It's required actually now. By the UBA precisely, but that's another point. The point is, I want to understand how this projects on the red bands. You used to have to demand double observations on the red bands, and that was an issue also for the clusters group because whatever, right? We need to have all the filters for the clusters, and yeah. So So don't we need now double exposure for the red pass if we do one times one, or can you?
For the blue.
No, I mean, the double exposure was for the red one.
Double exposure was the for tray 4.
Right.
And as usual, all trays are a mix of blue and red. So I let you as an exercise to figure out which ones are the filters from the red, from the 4th, right? So obviously these ones and these ones, right? So 1, 2, 3, 4.
Sorry, those are filters from the tray 4.
Those are filters from tray 4,
Assuming double exposure.
assuming double exposure.
I think that has to be recovered.
So if we don't do double exposure, of course those limits go up.
Right.
Is that a problem?
I see. I see. Okay. Okay. So we may lose this requirement of double exposure, not because they are deeper.
No.
They're not deep,
No.
they are deeper, right? Yeah, finally.
Right. These are two different things. So one thing is binning 2 by 2 may or may not be possible. And this is one thing. And this affects all the trays, right?
Sure.
On top of this, there's the other question. Years ago, we defined that tray 4 was supposed to have double exposure. Is it still the case? Do we still want double exposure on filter 4? Now that, well, regardless. Because, if we don't do double exposure on filter 4, filter 4 goes faster. And in that case, we may end up having 56 filters in the whole thing faster. Sure, we lose a little bit of depth. Is that something desirable? Is it desirable?
The question is, as you said earlier, how much of your science dies because of that?
Yes.
If it's critical, then you have to express it.
Right.
There is a seat now.
Carlos, the other Carlos was out there.
This is about one of the points of Rosa about Virgo, and I think that Virgo must be done, but in open time.
Okay. The open time is announced for in 6 months, so,
Yeah.
so we have to organize.
Or perhaps in survey mode, because at the end, if you want to do something with all the filters in open time, you need to go to more than 100 square meters.
That's right.
To make something that makes sense. So at the end, Virgo is an obvious choice. If I'm in the panel and anyone suggests it, I'm going to suggest it. Because it's obvious, as Rosa said, must be done. But we have that 20% that is going to be open.
That's an independent seat.
It's an independent thing. You can do it, and perhaps you do it faster at the end because you're going to have more priority that in some moments than they pass. So, I don't know.
You have more questions, Raul?
I have, at this point, I have two. The first one is that I remember back in, I don't know if it was 2009 or 10 or 11, one of the first meetings in Granada, we were figuring out the filters and so on. And I think
2010.
In 10, yes. So I did my own exposure time calculator and figured together with lots of people, I guess Fernando was there also. The reason why we're seeing this gap there in dark nights is because we are barely sky dominated in noise. We're just about sky dominated in noise. So if you do 1 by 1 binning, you get more readout noise. So I'm wondering actually, I mean, maybe you already checked this, maybe the answer is simple, but is there, if we are stuck with 1 by 1 binning, and again, big hypothetical because we really don't know, is it true still that in dark nights, 1 by 1, it's not worth by just reading out slower and with lower read noise? Because it seems to me that we are starting to get read noise dominated there in the dark nights. It might be the case, especially in the blue, in which case it would make sense to go for the next slower mode, even though we pay a price. It's better to read out slower than to expose more. It might be possible. Anyway, it's just to check. I don't know how, I abandoned my exposure time calculator a long time ago, of course, because it was ridiculous, but the principle is the same. Maybe there is, I remember Jesus had an exposure time calculator at some point. Oh, you have it. All right, good.
I'll
I'll check this.
I'll check. The issue there is since all the trays are mixed, you may have half, actually less than half of the tray which is not sky dominated or barely sky dominated, the other half, and actually more is. So
It would be more like if it's the darker the night, maybe it's worth reading slower, independently of the filter. Anyway, it's something that will come out of the ETC for sure.
Yes, it's the same exposure time for the detector.
No, we are the same at the moment.
But you don't have to. I mean, you could change it a little bit for the blue ones to read slower.
No, you want to.
You have to have the same readout for the whole campaign. Yeah. But even then, if the night is dark enough, it might make sense and might be checked. Anyway, just an idea, I don't know. The second thing is, if we can go back to your plot of all the science cases in the footprint there, can we go back?
Right, sure.
It's very quick, it's just an observation.
Yeah, I don't remember what it is.
It's, This, yeah,
no,
this one is
sorry.
or the other one. Everybody together, yeah, something like this. So, no, this is nice in order to have an idea about where everybody is. But of course, there's no way to give weight to science cases or to tell how much they last. This is what we have to bring to each group now and discuss. However, there was one thing which I didn't see. Maybe it's in my, still, I remember vaguely, but it's the speed with which we're doing our survey. Maybe somebody else is going to show this, but you remember the plots that Carlos created? And we didn't see here. And what is the speed when we have 2 trays, when we have 4 trays? This is something I don't recall entirely.
I didn't want, I was trying to redo them. There was something in my code which wasn't working well because, but in the good old days of Euclid plus I plus the 4 things, we were going at about 800 square degrees a year in trays 1 and 2, and of course the broadbands, and 200 square degrees plus or minus something in everything.
So you still,
yes. Sorry, I didn't
200. We were fulfilling the 200 square degrees requirement
per year in all filters. And 800 in the 2 blue.
800.
Yeah.
Didn't that include the Euclid G? Those numbers sound like.
Yeah, that was included.
That was it could be
G
easier now.
So now it should be easier.
Maybe it's a bit faster. Yeah, that's why I was asking.
So now it's a little bit faster. The thing is, it's a little bit faster. Because Euclid G, sure, it was a stupid depth, right? And it forced a stupid depth in I. So probably broadbands are going to go like half the time, but
You're wrong, my script. I just need to know the conditions. So the G band is gone.
The G band is dead.
What about the other pieces? So I had error and I for broad ones. I can consider just one of those, I guess.
So this
might be I. Right.
This is the other. So this is the other question, right? So, sorry.
So wait, can I comment? I also agree completely with you. What makes us different are narrow bands. We might very well have much deeper imaging in other bands from other surveys, but still we need a detection band, right?
Yeah.
So I entirely agree with you that we might focus on our central key.
Right. So
I
then
think
we'll
I
have
wish I could remove that from the discussion. Let's just settle on that. No, I mean, to simplify, right? Unless there is someone that.
I just want to run my script and see what are the new speeds with the new configuration. So I drop the G band and then I can consider have R and I or just
Only
one.
I.
Only I.
Only I.
So the only comment on that, and I know, so apparently I is critically important for some people, but I was just looking at the DESI Legacy Imaging Survey, which covers G, R, and Z. So apparently R is for free anyway, because it's public data, and I think it covers all the JPAS anyway. So R is for free, but maybe also, I don't know if the depth is enough that you could maybe build a source catalog for this instead. There's some other reasons for doing I. I'm just saying, maybe you don't need any broadbands. But it certainly doesn't seem that you need R because R is already available already.
In any case, the broadbands are relatively fast. They don't take up a lot of time. Yeah.
Especially if now we are stuck with only one broadband and that broadband is I is so little affected by the moon that we can basically do it whenever, as Eduardo would say, we can do I whenever the scene is good. So, and actually this makes also operation easier because JPCam has 5 trays and 4 are the narrow bands. One is broadband.
Right, yeah, told you.
Yes, it's paying attention.
One is, I was surprised you didn't say anything yet. One is the broadband tray. So if we only have one broadband tray, we basically put the instrument there, and in 30 years, when we finish the 5,000 square degrees, and we publish data release 1, we just take out the filters and
Just open to. And then again.
So on this, so on this question,
20 years.
So on this question of footprint, I think it makes total sense. I fully accept this point that different science teams need to have the discussions about what the response is to this question. But in broader terms, I think one of the things that I'm lacking, which I think is a broad picture, implicit in some of the things we're saying about tier 1 and 2, is some doubt about their footprint on a given timescale. Because we wouldn't really need to be having this discussion. I think people are generally happy to get their science if it's in year 1, 2, 3. This is not a major concern. The question is, how big will the survey be? What will we get ultimately? And it seems to me that your concern is partly coming from a question, how big is the survey going to be? And if it's not going to be 8,500 square degrees, I think it'd be good to know what it's going to be so that we can plan something so everyone's confident they'll get their science eventually. We can all agree on what the footprint is this area, we'll all get it over a certain number of years, and then we can busy ourselves with the question of in what order, which is what I want to talk about.
So my understanding here is that we moved from a fixed footprint to a sort of prioritized footprint, which we can even extend beyond these 8,000 square degrees that we typically talked, which is really talking about long time from now. So I would say the tier 1 plus 2 is getting to these 8,000 square degrees approximately. So
the numbers are
1
done
plus 2
exactly
is what should be considered the ultimate footprint.
Tier 1 plus 2.
Yes, and within which the priorities is 1 plus 2.
The numbers are done so that tier 2 is just about the original number. Tier 1 is a little bit less than half, and tier 3 is all you get. And depends how you stop.
So if
I'm trying to be on diet.
So yeah, so we really are saying tier 1 plus 2 is the survey.
Yeah.
Then I think that, I think it's useful to keep that in mind because otherwise people can start to doubt that they'll get their science or they get their data eventually. If we're accepting this is the survey, then I think people can relax a little bit in some respects. But really, I think what you want to do is you want to doubt that Stripe 82 is ever going to be in, right? I think this is part of the point that you want to make, right? There's the difficult areas that you don't want to see in the footprint at all. And, or on the other hand, if you've got 7 years, you just take 7 years to get it and you get it eventually, and that's fine. But then maybe, right.
But I think Stripe is more indeed tier 2.
Exactly, that's what I'm saying. So it's in there, so I'm not sure what the discussion is.
I just don't want to end up having troubles with Stripe 82 being in tier 1 and all of a sudden making it impossible to fulfill tier 1. And actually, if even worse, if it was in tier 1, I will start to observe that the algorithm will automatically assign a point in tier 2. And that one would override any observation in 72 whatsoever.
But in taking the weave experience, right, there's a schedule that's quite complicated. Clearly, JPAS has its own requirements, but there could be multiple seeds with priorities attached. If it's possible to observe Stripe 82, go there, right? Or you go to a different seed. But you can have multiple seeds that are all potentially observable.
But remember that it's a different kind of survey. It's not like weave in which
No.
you get the same science.
Everything.
Sure, no, I realise
Yeah, but
survey
it's
growth is
something
important, so
cheap,
you can't go nuts, you can't have an indefinite number, but you could have two that's accessible at any given time of year at two different declinations.
Take it like what Rosa was showing, I think was phenomenal, because it actually shows that, if you have one point where you can stay there for an hour in a night, it's like, yes, you made one observation. So what? Then you go back there the following night and you get another observation. So basically you don't grow there.
Yeah.
And effective, and since you're supposed to move the telescope and then you're supposed to refocus, effectively that's, I don't want to sound rude, but that is wasted time.
No, you can't just have the telescope sitting there doing nothing, that'd be crazy.
That's right. So instead of going to one point A, which you can only observe for 1 hour a night or 2 hours a night, you just go to one point in which you can observe for 10 hours a night, and you're much happier, right?
So is there much latency regarding going to one place to another, observing for a few minutes and then going somewhere else for a different degree? Is that much loss associated?
There is loss because you may have to refocus. We don't know yet. But the most important thing is basically you start growing at 1/14 of a half of a square degree.
I get that point about multiple filters, but if you do two places growing them at once, maybe it's not so bad. Right?
If they could grow at once, but the problem is that if they were observable for the same amount of time, I would get your point. But if they are different declinations, the southern one goes slower than the northern. Sorry, the one at higher air mass goes up.
But that's, yeah.
So that kind of brings, I mean, I every time you speak about this, I see the picture of this guy, which is equilibrating 10 plates at the same time, right? So that to add another plate, like Renato said, is it always going to be the case that having fewer seeds is optimal in light of the weather patterns? Is it always going to be the case that you are going to be contiguous in following that seed over a continuous amount of time? The weather is not going to interrupt you enough that you have to switch entirely to another field and lose a little bit here? Or is it better to hedge that by having a bit more seeds? I'm not talking about 100 seeds. I'm talking instead of 2, having maybe 3, 4 because of the weather. I have no idea. I'm just asking if this plate is something you have to worry about, or you just let it fall.
Patchy clouds. Yeah.
I think you have a cone of basically 80 degrees wide, which is your ideal area to observe. Okay, so whenever something goes over there, you need something else here. So let's say you have things in 60-degree distances in right ascension or something like that.
Right.
So you may need 2 in the south, 2 or 3 in the north.
Right. So those
like
two are separated by about that much. So maybe that's too few, no?
I guess it's
in the north.
This is, so for example, this and this are a bit desperate.
Yeah. And this and that, and
This
XVIII JPAS and the other one is like.
This is too short, but the problem is, this is too short, but again,
okay, all right.
I'm told, put this in,
Yes.
I put it in,
All right.
right? It says,
This is 4 hours in right ascension.
whatever.
I think the answer to your question was that weather isn't that much of an issue, right?
But-
Did I understand correctly? I think.
But yeah, long
just
story short, weather is not much of an issue. And the good
It
thing of,
doesn't dominate much.
All right.
It's-
Okay.
It dominates more the phase of the moon that is dominating when you can observe the moon.
Okay.
The field, the altitude of the field.
I think this discussion about increasing exposure in one of the traits is very important. I think we should concentrate more on this, because I agree with your proposal, which I understand was your proposal, that we should not do a double exposure in trait 4. But with this new depths which are shallow, they for us would mean that we will lose group detection, at lower redshift than what we have calculated, and increasing exposure in those filters that kind of sample that redshift, that would be a way to recover. Plus, of course, it always adds the bluest ones, as you show in this example. So to me, if you ask which one, give me 5 seconds of time, I say trade 3. But maybe after some thought, I say trade 2, just because maybe things are worse, and that's trade 2 is the one that's gonna do the weather in this case. But this of course requires some tests.
Are you talking about in light of bidding or completely apart?
No, I'm agreeing that they do one by one, and I'm just trying to see where we need to increase the exposure to recover the science that we lose otherwise.
But we might not do one by one.
I don't want to go into this discussion. I want to assume we do one by one and see what the solution is, because the 2 by 2 solution we know already.
I see.
It's all solved.
Okay. Yeah.
All right. I know the answer there. I need an answer now for 1 by 1.
I don't want to take merit from someone else. Someone else commented, do we still need to do the observation, the double the observation on trade 4? And I can't remember who that was. But basically it felt like an honest thing to ask. So I made it mine, and I'm asking. Honestly, I don't remember who that was.
Quiet, that's good. I'm going to go back to your final or almost final view graph.
Yeah, thank you.
So there it is somewhere. Okay, so this is important for some of you, but this is no.
Can we just a second leave?
You had a list of questions for the.
Yeah, this.
Well, this is okay. This is what.
So may I suggest?
Please.
I think the first one, I would say we forget about it for a moment, the 2 by 2, at least during this meeting, but it's something we should keep in mind to still discussing.
You're the sense that
That's my suggestion, maybe it's something we should still
Apparently,
discuss.
for technical reasons, the beginning is going to be the way it's going to be. So
yes, and we still have it's double exposure time to trade 4. Again, I think it's an interesting question that we may need to drop it. We may want to drop it. That was way for red galaxies and to get to red galaxies and try to 1.1 for BAOs, which at the moment is not the most hot.
Maybe not BAOs, but maybe for clusters we are pretty.
Indeed. But I'm not sure that, this was for red galaxy up to ratio 1.1.
Our problem is actually 0.6. 0.6.
If we 0.6, we go to trade 3, as Alexis was saying, 2 or 3. So we don't need to get to 3, 4. So that is an interesting point to think. If there is any trade, at this point it could be open, that would require deeper than what it is at the moment, right? Maybe assuming that we have to keep the 1 by 1 binning, or maybe with this case in mind, right? I guess the broadband filters, I think unless someone has different opinion, I think it seems that pretty much there is an agreement on the I band and being only that one. And I don't think there is much need to discuss that further.
And in case we blame it on Antonio, and that's it.
Sorry?
In case we blame it on Antonio.
Okay. And yeah, so effectively, really, the main discussion is the footprint. Really, what especially the time constraint, right, on the footprint. I think that's the key thing. And then
on the depths.
Yeah, I think the important point that more or less subsumes everything is depth. I mean, you think of the depth that you need, and then it will fix whether you need more time or whether the 2 by 2 is important or is impossible or.
So there is the depth issue, and then the footprint again, the priority of I need this area observed by that time, otherwise the game is out.
Yeah, exactly. So it's a time preference.
Yes.
Also an area preference.
This also relates with the filter preference. We want to observe all the 56 filters.
Yes.
Before Rosa. But
It's not me, it's the whole.
All of us.
do we want to observe all the 56 filters at the same priority? Do we want to
No, I
have?
mean, that also we agree, I think, let's not bring back things
so
that
we
we
are-
already closed.
Even-
That is all very close.
Yes.
Even before I let Carlinhos talk, I want to remind everybody, we've had this discussion for 15 years already,
Yes.
Wow.
that it's very, I mean, no, because sometimes it's
Not
hard to
quite.
just get it inside, apprehend it. But no matter what's the amount of area that's going to be done over the first year, if, because it's necessary, as you just said, a relatively large fraction of that first year will be done with all trays, because it has to be done with all trays, because we need to see all trays working. That's already a huge amount of data. So
Yes.
it's going to be difficult to think of somebody saying, no, but I need 20% more of tray X. You already have plenty of data to do things. And you may wait for the second year for that. But that's my personal thing. Carlinhos was going to say something, and
So one thing to take into account with APCAM is that observe 1,000 square degree, well, 100 square degree with one filter tray doesn't mean that you have an area observed with all the filters. So if you observe 100 square degrees, probably you are having with all the filters 40%.
Mhm.
So if you need all the filters, remember that even if you observe 1,000 square degrees and you start to be very patchy, you have 100.
But
all the filters.
that's why having,
first year.
yeah, well, that's why having the first year a contiguous region which is large enough is important because you grow from that region. And then when you add 100 degrees to that region, you really have a
That's why the number of seeds or the number of rows you want to be as small as possible.
Exactly.
Because then you grow much faster.
So I think this is now to the groups, whether we should, you want to have parallel sessions now?
Now.
big parallels.
Maybe one item
Mi grupo Monimu.
I think I know half of them.
I know about half, but we have a different half.
Hi.
That guy and you and you and you and you.
Oh, this is the real names though. No, that's the answers. We want the questions. Oh, I do that.
Why so many Italians?
Because Ringhio Gattuso is unavoidable, because Facchetti invented the role, because Zanetti is. Yes. Because Baggio is Baggio, because Paolo Rossi became some of the Brazilians. Maradona
Gattuso is so
some of the
bad.
Brazilians.
Alessandro, I have to say, as a Brazilian, it hurts a lot to put Paolo Rossi there on top.
I was telling him that I did it on purpose.
Then there is the.
And actually, I started to do this, and then I realized that it was actually supposed to be flipped, because I don't have a goalkeeper, which would have been Zoffo.
In defensa, interista
If we got applause, it's actually also for Antonio with his statement. I would suggest, I think now,
I think we're close. I mean,
Yeah.
I'm only 1 hour late.
so there are 2 more sessions parallel possible, plus all coffee, lunches, breaks. So I guess also some parallel activity can be thought at lunchtime, right?
Esto se puede poner para la sala.
Okay, so people that are connected, we are done today, so let's reconvene tomorrow
Tomorrow at 10, right?
at 10, yeah.
Okay, thank you. Bye.
Bye-bye.
Yeah.